So far, we have focused on programs written in C and C++. We've examined how vulnerabilities in programs written in these languages can lead to attacks that violate memory safety, resulting in remote code injection or theft of sensitive data. We've also looked at various defenses against these attacks. One effective defense is to use a memory-safe programming language. In this unit, we turn our attention to Internet security, focusing on applications that are part of the World Wide Web. While many web applications are implemented in type-safe languages and thus avoid memory safety issues, they have their own sets of problems. These problems go by names like SQL injection, cross-site scripting, cross-site request forgery, and session hijacking. Interestingly, the issues underlying web vulnerabilities are sometimes very similar to memory vulnerabilities. For example, SQL injection, SQL injection, and cross-site scripting arise because, like buffer overflows, the application's failure to properly validate its input results in it treating data as if it were code. The modern web, sometimes called Web 2.0, brings in the additional complication of mobile code. In particular, when you visit a website, code from that site will be silently downloaded to your machine and then run. Well, how do you ensure that this code does not violate the security of other programs running in your browser or on your machine? The outline for this unit is as follows. First, we will look into the technical details of the basic World Wide Web. We will see how typical web applications are structured at the client and at the server. We'll examine HTTP, the Hypertext Transfer Protocol, which client and servers use to communicate. We'll see how improper interaction with the database on the server can enable an attack called SQL injection. Next, we'll look at how web applications implement ephemeral, that is, short-lived, non-persistent state. Such state is useful during a long-lived session. Typically, ephemeral state is implemented using hidden form fields and cookies. Unfortunately, sloppy use of these features can lead to attacks such as session hijacking and cross-site request forgery, or CSRF. With these attacks, an adversary can take over a user's account or manipulate an application to act for that user, but in the adversary's interests. Finally, we'll look at so-called Web 2.0, which characterizes the modern web. The modern web makes heavy use of mobile code, often written in the language JavaScript. JavaScript programs originate at a server but run at the client. Running code at the client creates new possibilities for attack, one of which is called cross-site scripting, or XSS. With XSS, a user is tricked into running code he thinks is from a trusted website, but in fact is from a malicious source. Throughout the unit, we will look at various defenses to these attacks. One common theme of all of the defenses should be familiar: validate your input. So, let's begin by looking at the basics of the Web 1.0.